Assalamualaikum and good day. My name is Faiz Sulaiman bin Ismail, and today I will be telling you guys about slip casting. So what is slip casting? Slip casting by definition is involving the action of pouring liquid clay, or known as slip, into a mold. Hence it got the name of slip casting. So how do slip casting being done? Here are the several processes as shown in this slide here. So first, we have to find a mold. Then the mold is being poured with slip, and after that, after we left the slip for several hours, we have to drain the mold inside from excess slip. And after a period of time, the mold is being opened, only to left with the foam cast. So slip casting usually it is widely used in pottery, but they are also being used in making bathroom fixtures as well as designing some architectural elements. That is all from me. Thank you.
Next, we move on to powder pressing process. This is a process that uses powder metallurgy by using pressure to form materials such as metals, composites into our desired form. The process starts with powder preparation, where the materials must be in powder, and also to dye fillings. The third is compaction, where we apply the pressure, and ejection, and also sintering. Sintering is we heat up until the below the melting point, so the material can bond together. There are two types of powder pressing. First is cold pressing and hot pressing. Cold is for room temperature, while hot is for other temperature. The application of powder pressing can be seen in automotive, aerospace, electronics, and also medical section.
So in this part, we will see about the thermoplastic and thermosetting and what is the difference between them. So for thermoplastic, we can see that thermoplastic is a plastic material, and the shape can be changed when be heated, which is it becomes soft when heated and hard when cool. And this material can be reheated and reformed into new shape multiple times without changing its properties. And for thermoplastic, it consists very long chain of carbon atoms that are covalently bond each other. So for thermosetting, we can see that the thermosetting is formed in permanent shape, which is the condition is set by chemical reaction, and it cannot be remelted and reformed into another shape when applied with the heat, but it can be degraded and decomposed due to heat in too high temperature. This thermosetting also cannot be recycled. And for microstructure, we can see that for thermosetting, they are consist of network of carbon atoms that are covalently bond to form a rigid solid.
So between thermoplastic and thermosetting is thermoplastic can melt under the heat after curing, compared to the thermosetting. Thermosetting remain solid under the heat after curing. So thermoplastic can recycle, thermosetting can be recycled because thermoplastic they are remoldable compared to the thermosetting. For thermosetting, durability is very high compared to the thermoplastic. And then for application, example for thermoplastic, usually they use in create pipe PVC. And then for thermosetting, usually engineering used to create electronic housing, and then chemical process equipment. So that's all.
So we move to the next composite material, which is metal matrix composite, or MMC. MMC consists of non-metallic reinforcement incorporated into the metal matrix. MMCs are widely used in applications where the operating temperature is in between 250 degrees Celsius to 750 degrees Celsius. The metal materials used such as matrix include aluminium, titanium, copper, magnesium, and the alloys. The reinforcement phase for MMCs normally comes from another metal of ceramics, such as silicon, carbide, and alumina.
Material science, a polymer matrix composite. PMC is a composite material compound of a variety of short or continuous fiber bound together by a matrix of organic polymers. PMC are designed to transfer load between fiber of matrix. PMCs are composed of a matrix from thermoset, explosives, and phenolics or thermoplastic, polycarbonate, polyvinyl chloride, nylon, and acrylics. Polymers are used due to their room temperature properties that ease the fabrication process and reduce the cost. For example of embedded reinforced face used in PMCs are glass, carbon, steel, and caliber fibers. A perfect example for used PMCs in the construction of modern aircraft, the Boeing 787 Dreamliner primary structure, including the fuselage and wing, is made of 50% of PMC, and the Porsche 908 fiberglass reinforced plastic body shell weight just 180 degrees, and Vestas is the first company to introduce a carbon fiber composite bricks.
So we continue to the ceramics matrix composites, which is CMC. CMC is a special type of composite material in which both the reinforcements, which is solid fibers, and matrix material, ceramics. The characteristic of CMC is consists of metallic, non-metallic reinforcement incorporated into the ceramic matrix. And the second one is offer low density, high hardness, and superior thermal and chemical resistance. Third, CMC is wide in using in application where the operating temperature is in between 800 Celsius to 1650. CMC is a strongly increase in the fracture toughness. And then next, CMC is also enhance the fracture toughness of the combined material system while still taking the advantage of the inherent high strength and young modulus of the ceramics material.